Hello everyone, welcome to my YouTube channel. In my last video, I have discussed about the definition of unitary matrices and orthogonal matrices. I have also taken some examples. Today I will discuss the definition of idempotent matrices. So a square matrix A is called an idempotent matrix if A square equals to A. Now if we write the characteristics equation for this matrix, this must be x square minus x equals to 0. If we take x as common, this becomes x into x minus 1 equals to 0. From here, we can say that the value of x is 0 and 1. So the eigenvalues of such kind of matrices are 0 and 1. The eigenvalues of an idempotent matrix are 0 and 1. Now, if we discuss about some examples, so all the matrices whose eigenvalues are 0 and 1 are involutory. For example, the first one that I am taking is a 2 cross 2 identity matrix. If we multiply it with 2 times, again we get an identity, that is A square is equals to A is holding in this matrix. So this matrix is an involutory matrix. Now if we take this matrix 1 0 0 0 and we do the square of this matrix, again we get the same matrix. That's why it is also an involutory matrix. This is also an involutory matrix. Moreover, I want to tell you an important property of involutory matrix, that how you can recognize that the given matrix is involutory if it is given in this form. So an n cross n matrix with all entries 1 by n is also idempotent matrix. For example, here I have taken 2 cross 2 matrix, so I have to take all the terms as 1 by 2. If I will take n cross n matrix, then I have to take all the terms as 1 by n. So this type of matrices are also called idempotent matrices. So we have discussed about the definition of idempotent matrix, its eigenvalues and some of its examples. Now we will discuss some of its properties. So the properties of an idempotent matrix is as follows. The first property says that if A is idempotent matrix, then I minus A. What about I minus A? This will also be an idempotent matrix. Idempotent matrix. And this question was asked in CSIR net, that if you have an idempotent matrix, what can you say about I minus A? So that must be an idempotent matrix. And I will conclude it how it is possible. So if we apply the definition of idempotent matrix over this matrix I minus A, we have to write I minus A whole square. Now if we are able to show this term as equals to I minus A, then we say that I minus A is idempotent matrix. Now this can be expressed as I minus A into I minus A. And if we solve it, this becomes I square minus AI minus IA plus A square. Now since the matrix A is an idempotent matrix, so A square must be equals to A since we have taken it. So I square becomes I, because if I is also an idempotent matrix, so I square must be equals to I. And this can be expressed as minus 2IA plus A. Now if any matrix is multiplied with identity matrix, again we get the same matrix. So this becomes I minus 2A plus A. And if we solve it, this becomes I minus A. So what we have done, we have taken I minus A square matrix and it becomes I minus A. This implies what? I minus A is an involutory matrix. Sorry, idempotent matrix. So I hope the definition of idempotent matrix is clear to all of you. Now I will discuss about the involutory matrices. So the definition of involutory matrices are as follows. A square matrix A is called an involutory matrix if A square equals to identity matrix. So this time if we want to calculate the eigenvalues of this matrix, we have to write the characteristics equation. Then x square minus 1 equals to 0. And if we write the eigenvalues of this matrix, this becomes x is equals to 1 comma minus 1. So two eigenvalues of involutory matrices are possible, that is 1 and minus 1. So the eigenvalues of involutory matrices are 1 and minus 1. Now we will discuss some of its examples and some of its properties. Every identity matrix is an involutory matrix, because if you take the square of this identity matrix, you will again get the identity matrix. So A square is equals to I is satisfied by this matrix, so it is an involutory matrix. Now if I take one more example, so consider minus 1, 0, 0, minus 1. That is a matrix whose diagonal elements are minus 1. Now if we take the square of this matrix, A square, this becomes minus 1, 0, 0, minus 1, multiplied with the same matrix, minus 1, 0, 0, minus 1. After taking the multiplication, we are getting an identity matrix of order 2. So this becomes A square equals to A square equals to I, sorry. This implies A is an idempotent matrix. Involutory matrix, sorry. Now we will discuss some of its properties. So the next property is as follows. If A and B are involutory matrices, and AB is equals to BA, then AB is also involutory matrix. Then AB is also involutory matrix. In order to prove this, we have to show that AB whole square is equals to identity. So AB square can be written as AB into AB, or if we use the commutative property of multiplication, this can be expressed as A into B into B, and this can be written as, since A and B are involutory matrices, then we can write it as I into I, that is equals to I again. So from here we can say that AB is also an involutory matrix if A and B are involutory matrix. So I hope the definition of involutory matrix and idempotent matrix is clear to all of you, and the properties also. So I hope you are liking my content. If you are liking my content, please subscribe my channel. Thank you.